In this video, we will talk about the functionality of data mining. When we have a large amount of unannotated data, we can also use this data to train our model. Previously, we mentioned that we can label all the data to create a labeled dataset for use. However, when the amount of data is very large or the cost of data labeling is very high, for example, some datasets require professional personnel to label, the cost of fully annotating the data is too high. On the other hand, images from the same source often have a large number of similar pictures, and utilizing these images to improve the performance of the model is often very limited. To address these issues, data mining utilizes active learning algorithms to identify the most effective images from a large dataset that can improve the model's performance. Only a small number of images need to be labeled to quickly improve model performance, while also improving the quality of the dataset and removing similar images. First, we need a small number of labeled images, such as 500 or 1000 images. We can use public datasets or manually annotate them. Train an initial model. Assume it has been trained. Next, we use a larger dataset, which can be labeled or unlabeled, to improve the performance of the initial model. Take the 8.29K dataset in the figure as an example. Click here to find the mining button and open the data mining page. Select the algorithm mirror, target detection, and choose the initial model. Then input how many images you want to mine, such as 20 in this example. Adjust thresholds and the hyperparameters as needed, and click the mining button. This will create a mining task, where the platform will use the selected initial model to calculate through all 8.29K images in the dataset and identify the 20 most useful images for improving the model, forming a new dataset. The generated dataset will display mining labels here, and further annotations can be added in the future. Since our initial dataset is already labeled, the mined dataset also has labels. We can merge the mined dataset with the initial model's training dataset. Select both datasets and click the Batch Merge button. For duplicate images, you can choose to keep the annotations from which dataset. You can also select an excluded dataset to exclude any images that appear in the excluded dataset. Finally, click the OK button, and a merged dataset will appear here. At this point, we can use the new dataset to train the model again. If you feel that the effect is not satisfactory, you can continue to mine the most useful data from the large dataset. Here's an estimation of the actual application scenario. If we have several thousands of unannotated images, we can mine 1000 images at a time and iterate 5 to 10 times to obtain 5K 10K high-quality images. At present, the outsourcing annotation price is about $100 in total. If we label it ourselves, it will take maybe 50 hours. Training time also takes 50 hours. If we label during the day and train at night, the whole process will take about a week, which achieve the effect of using the entire dataset for training. Therefore, using data mining function can significantly optimize training. And for enterprises, these mined data become private high-quality dataset. In the future, when updating algorithms and iterating models, only these data are needed to quickly complete the task, without starting from tens of thousands of unannotated data. You can also adjust the number of images to be mined in each iteration according to your actual needs.